Hey guys, I just spent 15 minutes recording this video and then realized that my microphone was plugged into the wrong interface. I had it plugged into my mixer instead of my interface. So yeah, here we go again. I just wanted to give a quick demo of a project that I've been working on for a little while now. Forgive the messy code, but it's a project called PropsJS, and it's basically a game engine, an animation engine. It handles basic physics. It handles creating animated scenes on HTML5 canvas, adding objects to the screen, removing them from or to the scene, and removing them from the scene. And I should have done this before I started recording. I'm just gonna give you guys a little demo and a little rundown of how it works and how it looks. So first we'll just start with some visuals. So you can see that I have an animated scene going here. This is all working on HTML5 canvas. These blocks are being added to the screen in response to a key press, and you can see that they have a velocity and a friction. So their movement looks fluid and realistic, and they slow down and come to a stop at a certain point. And what else? Let's just hop into this mode here because this is fun. So these objects are being added to the screen in a loop in response to in response to mouse move events. So I think it's just there's a loop that adds 4 or 5 different objects to the screen and gives them a random velocity in a random direction. And we get this kind of cool particle behavior that kind of looks like fish food floating on the surface of a fish tank. And we can push these blocks around with it. So let's do a little demo of the syntax and see how the code actually looks. So just push this down here. So this is how we create a scene. So the library provides 2 objects. It provides two classes, a scene class, and that class is it's your animated scene basically. So it keeps track of all the objects. It updates the objects every frame of animation. And so the way that we create a scene is in our HTML, we create a canvas element, and we give it an ID, and we pass that ID as an argument to the constructor function here. And then we just give it a height. We give the scene a height and a width, and we call the start scene function here and just specify the scene that we want to start, just passing that in as an argument. And then let's take a look at how objects are added to the screen. So I'm going to come down here. Excuse the terrible state of this file. This is what I've been using for testing as I've been building the library. So yeah, it's kind of a mess. So this little block of code here is how we add objects to a screen. You can see that it actually exists inside of an event listener. So objects are being added dynamically in response to a key press here. So we get this nice kind of declarative, almost CSS looking syntax from the library. So we're just basically calling a method called add, which is a method on the scene class. We're specifying the scene that we want to add to, and we just pass in this options object, and it just lets us use these properties to describe what we want our object to look like and what we want it to behave like. So we can give it a shape, we can give it a width and height, a position, and the position I've given it here is just the user's mouse position, color, fill, and then if we come down here, we can give it custom properties, and we can give it custom functions and collision functions as well. So custom properties is basically just anything that the developer sees fit to add, anything that they think, any information that they think should be stored along with the object. So What I've done here is I've given it a health property. I've given these objects a health property of 5. And then custom functions are going to run every frame of animation, so that's 60 times a second. And collision functions are going to run every time the object is involved in a collision. So I've given a collision function called hurt, and what that's going to do is decrement the health property every time the object is involved in a collision, and it's also going to make the object, I think, 10% smaller. And then I've given it a die function as a custom function, and that is going to, every 60th of a second, every frame of animation, it's going to check if the health property is below 0, and if it is, then the object's going to explode and into a couple little pieces, which are themselves are props being added to the screen in a function. We also have a friction and a mass. So mass is going to affect how it behaves in collisions with other objects. If it collides with something whose mass is larger, then it's not going to move that object very much. And if it collides with something whose mass is smaller, then it's going to move that object more. So I'll just give a demo of these custom functions and the custom properties and how they work together. I'll just go back into the demo here, and let's just check. Did I save? No, I didn't. There we go. So we can see that as the objects are colliding, the hurt function is running, and it's making the prop a little bit smaller, 10% smaller. And then when it has collided several times, it will explode, adding a bunch of new props to the screen, and those props are traveling in random directions with random velocities. So another thing that I've implemented here is spatial partitioning to optimize the collision algorithm. So if anybody doesn't know how collision works or how collision algorithms are implemented, basically what happens is every object checks its position against the position of every other object on the screen every frame of animation. And if its position overlaps with another object's position, then we know, or then the computer knows that there's a collision taking place, and we can run some logic to respond to that collision. In this case, we're running some logic that says, move the objects far out of collision and then adjust their velocities to make it look like they've bounced off of each other. So that's how it works. And the problem with that is that it's pretty expensive. There's a lot of checks happening every second, right? I think it's n times n minus 1 checks every 60th of a second, where n is equal to the number of objects on screen. So it's a ton of checks. And if you have a lot of objects on screen, it's going to really slow your simulation or your game or your animation down a lot. So what I've done is I have implemented a spatial partitioning system. It's just a basic grid, and we'll set it to. So it's actually running right now, but I'm going to run it. I'm going to set it to actually be visible. So now we can see we have this. I'm going to make it a little bit bigger, actually. Just makes demonstrating a little bit easier. Just make it. Okay, so we have these squares, these cells, and the way that this is going to help is it's going to tell the computer to only compare two objects' positions if they're in the same square, if they're touching any of the same squares. So for instance, these two objects right now are not being checked against each other for collision. But if we put two close together and touching the same squares, then they are going to be checked for collision. So we can see that these two do have squares in common. They share these two squares in common, so they're going to be checked against each other for collision. So yeah, I'll just add some stuff to the screen. Do I guess a little bit of a do a little bit of a stress test here. You can see we're still getting some smooth movement, and it is JavaScript after all, so it's not always going to be super duper fast, but it still helps. And in most use cases, it, I mean, if you're building a game or something like that, it's not always, it's pretty rare to have, like, I think there's probably like 2,000 objects on screen right now. That's a really high number, and there's not a lot of use cases where there would be that many objects on screen. But you can see even still it was running fairly well. So is there anything else that I forgot to mention? So the physics is handled with just a little vector library that does some really basic math with really basic vector math. And I built that. It was more of a code along with a series. That's a YouTube series called Coding Math. So I learned a lot from that. And if you guys want to learn to do the same stuff, you should check that out too. Just Coding Math on YouTube. And what else? Some steps for the future that I have to take with this project are letting users add bitmaps. So right now you can only just basically give the object a fill and a color. So I'm gonna have to make it so that you can add like a picture to the screen. Like you could draw a character or maybe a terrain tile, and have your object look like that instead of just a colored square. So that's something that has to be done. And I guess in that case, these objects would actually act more like hitboxes. And then the other thing that I want to do is just give users more control over collision behavior. So right now, this massive, really messy looking function is how it handles the collision response. So when you see two objects bouncing off of each other, that's the function that's responsible for it. And there's a lot of numerical values in there that I always adjust, and I'm always tweaking, trying to get the collision to look perfect. And I realized, as you can see in these really long comments here, that it's probably a better idea to just let the user, instead of me trying to figure out the perfect collision, the perfect values for a perfect looking collision, I should probably just let the user do that and let the user be able to adjust those values themselves, and that way they can simulate different materials, and they can make their objects look more like more like rubber, or more bouncy, or whatever. So yeah, that's something that I also want to implement. The project has a long way to go. If you can see the state of the file structure and everything, it's really disorganized. So I hope to get it up and running in usable order sometime in the next few months. Yeah. So there you go. PropsJS. Thanks for watching.